Let's talk about synthetic division. In our last video, we talked about polynomial long division, but who really likes doing long division anyways? There's a lot of steps, there's a lot of stuff to keep track of. You got to keep writing these variables over and over and over again. Synthetic division is much faster and simpler. There is one catch though. In order to do synthetic division, the divisor has to be in this form. Must be in the form x minus a. And the reason for that is because we will be using the root of this binomial whenever we do our division. If you have a coefficient in front of the x, you can also make that work. You're just going to end up working with a fraction, and you can still do your synthetic division. But if x is raised to a different power other than 1, I don't recommend using synthetic division. You could still do it, but at that point, it is just straight up faster to do long division. So stick with that. Let's take a look at an example and how we're going to do synthetic division. For our first example, we have x squared plus 5x minus 3 divided by x plus 2. We have our divisor in the form x plus or minus a, and so we know we can do synthetic division. Here's how to set that up. You're going to set up a box that looks like this, and on the outside right here, you're going to write the root of your divisor, which is -2. Remember, the root is whatever would make this equal to 0. And then inside, we're just writing the coefficients for this binomial. We have 1, 5, -3. And here's the process. You take your first thing, or your first number, drop it down. Multiply these two together to get -2, and then we add this column to create our new number down here, which will be 3. Multiply 3 times -2 gives us -6. Add this column together, and that gives us -9. And then our pattern for writing out our final answer is our last number is our remainder, our next number is our constant, and then we have our x to the first, and then x to the second, x to the third, etc., going on back towards the left. So we're going to have x to the first plus 3. Oh, that is a terrible 3. What is going on? I'm going to keep that in because that's funny. X plus 3 minus 9 over this binomial x plus 2. And that is the final answer when we do our synthetic division. Let's take a look at another example. In this case, we once again have our variable raised to the first power, so we can use our synthetic division. Let's set up this little box. Our root, in other words, what makes this equal to 0, is a +6. And let's write out our coefficients. We have a +1, a -1, and a -29. First step, as always, is dropping down the 1. Multiply 6 times 1 to make 6. Add these together. -1 plus 6 is 5. Multiply these together to get 30. Add these together and get 1. And the pattern for writing out our final answer is remainder, constant, x to the first, and then x to the second, etc., going back on to the left. So we'll have x to the first plus 5 plus 1 over our divisor up here, n minus 6. And that is our solution to this division problem using synthetic division. For our next example, we have r squared plus 14r plus 38 divided by r plus 8. Write out our box, and our root is -8. Our coefficients are 1, 14, and 38. As always, first step is dropping down this number. Negative 8 times 1 is negative 8. We add these two numbers together. So 14 plus a negative 8 is a positive 6. Multiply these together, get a negative 48. Add these together. 38 plus negative 48 is negative 10. And finally, we have remainder, constant, r to the first. Oh, I just realized we have r twice. I'm going to write this as x to the first for now. X to the second, etc., going back off to the left. So we're going to have r, 1r, plus 6 minus 10 over our divisor, r plus 8. And this is our final answer. For this example, just like the last video, we noticed that over here we are missing our x term. Just like in polynomial long division, whenever you do synthetic division, you do need to have all of the terms explicitly listed. So let's do that. We're going to rewrite this as x squared plus 0x minus 74. And these are the coefficients that we're going to work with. Let's set up our box. Our root, so what makes this 0 is a positive 8. Let's write out our coefficients. We have a 1, a 0, and a negative 74. Now, we drop down our first digit, as always, multiply to make 8, add these together to get 8. Multiply 8 times 8 is 64. Add these together and get negative 10. Our pattern will be remainder, constant, x to the first, x to the second, etc. going on back. So our final answer will be x plus 8 minus 10 over x minus 8. Plugging in this divisor as our denominator. And there we go, our final answer for this problem. All right, for our final example, I wanted to use a longer polynomial and wanted to make sure that the coefficient on our leading term was not 1, so we can take a look at what that looks like. Firstly, we're going to make our box. Let's see, we have all of our terms, right? Cube, squared, 1, and constant. Perfect. So we don't need to add any more terms in. The root for this binomial is a positive 4. Let's write out our coefficients. We have 2, 5, negative 32, and negative 7. Same process applies as before. Drop down this digit, multiply these together, add down this column, multiply these together. That's going to be 40 plus 12 is 52. Add down this column, get 20. 4 times 20 is 80. Add down this column, and we have 73. And the same pattern applies before for writing out our writing out our terms. The first one is remainder. Then we have our constant, x to the first, x to the second, then x cubed, etc. going backwards. So our final answer is 2x squared plus 13x plus 20 plus 73 over this divisor, x minus 4. And that is our final quotient after doing our synthetic division for this polynomial. That's all I have for you today. If you found this video to be helpful, consider liking and subscribing, and if you have a topic that you want me to cover in the future, leave it down in the comments below. As always, have a fantastic day.